Welcome back to Business Mathematics 2 MA 1203. So we are going to continue with the linear programming chapter that is on the problem formulation of linear programming problem. Let's start. So this is a definition of linear programming. So linear programming consists of a linear objective function to be optimized. It can be maximized or minimized, subject on condition to a certain constraint, that is condition in the form of linear equation or inequalities. Okay, the objective function is the function to be optimized. We usually call the objective function. It can be profit to be maximized or cost to be minimized. And constraint can be described the limitation of a source. This can be the limitation of material, the limitation of time, the limitation of number of human resource, and so on. Okay, so the linear programming problem is just we want to find we want to optimize, we want to maximize or minimize a function that is a linear function given a certain constraint, that is we usually have the linear inequality. Okay, so this is the problem. A certain company produce two kinds of souvenir. That is type A and type B. Each type A, B, and give this profit. To produce 1 unit of type A requires 2 minutes, 1 unit on machine 2, while for type B you can look at this, 3 hours per day, 1 minute, okay, and machine 1 can only be used for 3 hours per day, while machine 2 can only for 5 hours a day. Find how many souvenirs of each type must be produced to maximize the profit a day. Okay, so this is the production problem. So we are going to look at the problem formulation. There is this problem, yeah. Okay, for type A, you have 2 minutes 2 minutes at machine 1 and 1 minute at machine 2. Okay, yeah. And for type B, you have 1 minute on machine 1 and 3 minutes on machine 2. Machine 1 can only be used 3 hours per day. So machine 1, the total time is limited to 3 hours. You can use it no more than 3 hours. And for the machine 2, it can only be used under 5 hours. Okay, yeah. So, and the profit for the first type A is $1 and $1.2 for type B. So I want to find how many souvenirs of each type. Don't forget, in problem formulation, you have to define first your variable. Because you are asked on how many souvenirs, so you have to let X and Y be the number of souvenirs to be produced for type A, and Y is the number of souvenirs to produce for type B. Okay, yeah? And the objective function, you want to maximize the profit. If you have X unit of type A, so the profit is given by 1 times X. And the profit for type B is 1.2 times Y. So the total profit is 1X plus 1,2 times Y. Okay, this is the objective function, the function to be optimized. We usually use Z, or you can use another variable, that is P, profit, or anything else. Okay, and the constraint. Don't forget, the number of souvenirs should be non-negative. That is, X is greater than or equal to 0. The same as for Y. And you look at the limitation of time for machine 1. So if you want to produce X unit of A, for type A on machine 1, you need 2 minutes. So if you produce X unit, so you need 2X minutes. Okay, yeah? What about time spent in machine 1 for type B? If you want to produce Y, so you should have 1 times Y. So the first one, 2x plus y, is less than 3 times 60. 3 times 60. Okay, so the limitation, this is the limitation. 2x is how many minutes spent on the machine 1 for X unit of type A. So this is the total time for type B if you want to produce Y unit, and this is the total time you spend on the machine 1. And the total time you spend on machine 1 should be less than 3 hours. That is 3 times 60 minutes, because this is on minutes, yeah. This is minutes. This should be minutes also. So 3 times 60. What about the second one? You can use the same interpretation. So you have x plus 3y is the total minutes spent on the machine 2, and it must be less than or equal to 5 times 60. Okay. Remember, in linear programming, we usually have limitation. So in the previous chapter, we usually learn if we want to spend all the time. So if we just want, this is the maximum time, you have an inequality. Okay, yeah? If you want to spend all of your time, you have equality here. Okay, yeah? This is, you have to spend less than 3 hours, less than or equal to 5. So you have less than or equal sign here. Okay, this is I think the last one, nutrition problem. A nutritionist advised a patient with iron and vitamin B deficiency to consume at least. So you have to consume greater than or equal to 2000 of this and 2000 of this. Okay, and okay, for some range of time. There are two kinds of pill, that is brand A and brand B. Each pill of brand A costs 6 cents and it contains this, while every pill on brand B is this and costs 8 cents. Find the combination of pills to be bought so that it satisfies the prescription and minimize the cost. Don't forget to consume at least. In the previous chapter, to consume, you have to consume this much. But this one, you have at least. So you have this one, you build the table. For the brand A, you have 40 milligram iron, this one, and the cost per pill is 6 cents. For brand B, you have this specification. Okay, and the iron requirement, the minimum requirement is 2400, and vitamin B1 is this, vitamin B2 is this. Okay, so don't forget, in the problem formulation, you have to define your variable. So find the combination of pills. So you have to define X is the number of pills of brand A and Y is number of pills of brand B. Okay, so objective function to be minimized, you want to minimize the cost. If you buy X pills of brand A, so the cost is 6 times X. If you buy Y pills of brand B, so you have add 8Y. So the total cost is 6X plus 8Y. So this is the function to be minimized, the cost function. What about the constraint? Don't forget, this is the number of pills, so it should be non-negative. X is greater than or equal to 0, and Y is greater than or equal to 0. For what about the first one? If you take X pill of A, Y pills of B, so the iron will give you 40X if you consume X pills of A, 40X. And you have 10Y if you use Y pills of B. So the total 40X plus 10Y is the total iron if I use X pills of A and Y pills of B. So the total iron that I consume, it should be greater than minimum requirement, greater than or equal to this. Okay? And you can do the same thing for the vitamin B1 and the vitamin B2. So you have this 1, 2, 3, 4, 5 constraint. Okay, yeah? and try doing some problem formulation of linear programming problem. This is very important. Define your variable, define your objective function, and define your constraint. This is very important in linear programming problem. If you fail to define your problem, you will get confused in your way. Okay, and you have to define properly the objective function and the constraint. Okay, try to learn this and try to do lots of exercise to learn how to give a problem formulation of a linear programming problem. Okay, that's it. And then we will look at the first method, that is method of corner. Okay, thank you.